Welcome to the DIY Honda Garage channel. The DTC P0723 indicates an intermittent failure related to the output shaft, countershaft, speed sensor in the Honda Pilot models from 2016 to 2022. This diagnostic trouble code signifies that the vehicle's system encountered an issue with the electrical circuit concerning the sensor, which typically resides within the transmission assembly. The output shaft speed sensor plays a crucial role in measuring the rotational speed of the countershaft inside the transmission, providing critical data to the engine control unit, ECU, for optimizing engine performance. If this sensor fails, it can lead to incorrect readings, affecting vehicle functionality as it may disrupt the seamless operation of the automatic transmission. To troubleshoot this issue effectively, it is important to focus on electrical connections rather than mechanical problems within the transmission. Therefore, inspecting the circuitry and connections becomes paramount. The output shaft speed sensor is responsible for measuring the speed of the output shaft, a vital part of the automatic transmission system. Specifically, it helps track the rotational speed of the countershaft, which impacts various transmission functions. Located within the transmission assembly, this sensor relays speed data back to the engine control module, ECM, for processing. When the DTC P0723 is triggered, it indicates that the sensor may be experiencing intermittent failures due to issues within the electrical circuit connecting it to the ECU. It's vital to understand that this code does not point to mechanical damage, but rather faults in the electronic signaling from the sensor. Diagnosing this effectively enables focused repairs and helps restore the vehicle's operational integrity. The possible causes of the DTC P0723 primarily stem from electrical circuit problems rather than mechanical faults. One major issue can be poor connections within the wiring harness that links the output shaft speed sensor to the powertrain control module, PCM. Loose terminals can disrupt signals, leading to intermittent failures. Sensor malfunctions could also contribute to this error by providing inaccurate speed readings, thus triggering the DTC. It is essential to systematically eliminate these possibilities during troubleshooting to accurately identify the risk points affecting sensor performance. Such awareness can assist in ensuring that the repairs are targeted effectively, avoiding unnecessary component replacements. Vehicles affected by DTC P0723 may exhibit several symptoms indicating a transmission-related issue. One significant symptom is erratic transmission shifting, where the vehicle may shift gears unpredictably, leading to a jerky driving experience. A malfunction in the speedometer can also occur, resulting in inaccurate speed readouts that may confuse the driver. Additionally, the check engine light may illuminate on the dashboard, alerting the driver to a fault within the engine management system. During acceleration, drivers might notice a loss of power as the transmission fails to operate correctly due to faulty sensor readings. Identifying these symptoms early can significantly aid in both faster diagnosis and resolution, enhancing overall vehicle reliability and performance. The first step in troubleshooting DTC P0723 involves verifying the problem's existence and ruling out any immediate concerns. Start by turning the vehicle ignition to the on mode without starting the engine. Next, clear the diagnostic trouble code DTC using the Honda Diagnostic System, HDS, to reset the system's error memory. After clearing, raise the vehicle securely on a lift, ensuring that all four wheels can rotate freely while testing. This step is crucial as it allows the technician to observe the vehicle's performance during an active test phase while also ensuring safety. Once the vehicle is raised, start the engine to prepare for further diagnostics, yet avoid exceeding the safe operating speeds during this preliminary evaluation. In the second troubleshooting step, Focus on the Voltage Control Circuit 1, VCC1 line to determine if it is functioning correctly. Turn the vehicle ignition to the off or lock mode. Then, proceed to disconnect the output shaft countershaft speed sensor 3P connector for access. Once the connector is disconnected, turn the ignition back to the on mode to allow for voltage measurement. Using a multimeter, measure the voltage between test point 1 and test point 2, where test point 1 corresponds to pin number 3 of the sensor connector, and test point 2 is connected to body ground. Ideally, the voltage should be around 5 volts. If this voltage is present, the VCC1 wire is confirmed to be functional, and you will proceed to the next troubleshooting step. If the expected voltage is absent, this indicates an open circuit in the VCC1 line, warranting repair before moving further. The third troubleshooting step aims to assess the function of the NC, no connection line, by measuring the voltage across the sensor connections. Ensure the vehicle is in lock mode again for safety. With the output shaft speed sensor 3P connector still disconnected, measure the voltage between test point 1 and test point 2, where test point 1 corresponds to pin number 2 of the connector, while test point 2 connects to body ground. The ideal reading should show about 5 volts, confirming that the NC line is operable without issues. A positive reading indicates that you can proceed to the fourth step for continuity testing. However, if the voltage level does not meet expectations, you will need to check the wiring for faults, leading to potential corrective actions in the next step. In the fourth troubleshooting step, you will focus on checking the continuity of the SG1 line. Turn the ignition to the off or lock mode once more, and ensure that the output shaft speed sensor 3P connector remains disconnected. Assess the continuity between test point 1 and test point 2, where test point 1 corresponds to pin number 1 of the sensor connector, and test point 2 connects to body ground. For correct functioning, there should be continuity, indicating that the SG1 wire is intact with no breaks in the circuit. If this condition is confirmed, then you will move forward by replacing the output shaft speed sensor, as it may indicate a fault in the component itself. In contrast, if continuity is absent, proceed to check the SG1 wire for potential damage or disconnections, ensuring thorough repair actions can be undertaken. The fifth step entails assessing the NC line for short circuits, requiring careful disconnection of both the output shaft speed sensor and the PCM powertrain control module connector. First, ensure the ignition is off, as it minimizes the risk of short circuits or electrical damage. Jump the SCS service check signal line with the HDS and wait over a minute to stabilize the system. Next, disconnect the PCM connector C, which typically has 51 pins for direct access to the control circuitry. Afterward, you will check for continuity using the same test points as before. Pin number 2 of the output shaft speed sensor connector compared to body ground. A positive continuity test suggests there's a short to ground somewhere in the NC wire, necessitating repairs in that area. If no continuity is found, it indicates an open circuit in the NC line, requiring different rectifications to restore functionality. After completing all troubleshooting steps and addressing any identified issues, it's crucial to perform a final repair verification. Begin by reassembling all components to ensure everything is correctly fitted and secured. Once reassembled, clear the diagnostic trouble codes DTCs again using the Honda Diagnostic System HDS to reset the electronic monitoring systems. Following this, take the vehicle for a comprehensive test drive under varied conditions, such as different speeds and accelerations, to confirm that all systems operate smoothly. During this driving test, Pay special attention to any signs of erratic shifting or activation of warning lights. If the vehicle performs as intended without triggering the DTC, it can be considered successfully repaired. Document all findings and actions taken for future reference and validation. Preventive maintenance plays a vital role in mitigating DTC P0723 in the future. Regular electrical inspections and maintenance of components related to the output shaft speed sensor can prevent issues from arising. This includes routinely checking the wiring harness for signs of wear, corrosion, or damage that could disrupt electrical flow. Keeping connectors clean and free from debris ensures that electrical signals can transmit without interference, reducing the risk of intermittent failures. It is advisable to create a maintenance schedule that includes these inspections every 30,000 miles, or as recommended in the owner's manual. By adopting proactive measures, vehicle owners not only ensure optimal performance, but also enhance longevity by avoiding more extensive repairs later on. In conclusion, diagnosing and addressing DTC P0723 in the Honda Pilot requires a concentrated focus on the electrical aspects of the output shaft speed sensor. Understanding the role of the sensor and the implications of intermittent failures facilitates a structured troubleshooting approach. Following the outlined systematic steps ensures a thorough examination of the electrical circuit and components, thus pinpointing the cause effectively. Additionally, implementing preventive maintenance measures will play a crucial role in minimizing the chances of recurrence. By prioritizing both immediate and long-term strategies, vehicle reliability and performance can be significantly enhanced, creating a safer and more enjoyable driving experience. Always remember to document repairs and findings to contribute to improved practices during future servicing. Please like and subscribe to the channel. See you next time.